Yes.
So the final is going to be multiple choice?
Yes.
Okay.
But you will have a scrap paper because maybe you have to do the math problem and you cannot touch the question because I need to return the question and give it to the department. And this is very strictly yesterday, Dr. Gabriela was telling me because they don't allow the extra question. Whatever the printed question they purchase from us, that are the fixed they are using every year. So it is very important that it doesn't leak or it doesn't spoil by writing or something. Okay. And if you have a time, you have a chance for the recorded lecture and topic wise, I always focus on the points that are important for the specific topic. So if you have a chance, you can go through from anywhere, anytime. Okay. So we are going to talk about the gas. We already saw and learned so many things about the solid, liquid. We know the particle, how it behaves, the solid, liquid, and gas. We know that normally gas particles are free flowing. They do not have the intermolecular forces, so that's why they can move freely and they don't have their shape. Normally, whatever the container we put, gas take this place, and there are some real gas and ideal gas. So today's chapter, we are going to learn about the properties of ideal gas and how they are influenced by the pressure, temperature, and the ideal gas law, and finally the influence on kinetic energy. This chapter is totally about math. So you have a little bit of basic to learn, and what you have to do, you have to practice the math. So that's why I'm telling it's okay that everybody will not fond of so many mathematics, but this math is not the algebra or higher geometry kind of things. I think this is interesting, but you need to practice. As I saying that if you practice, your final exam will be very good, I believe. It doesn't matter because they are not going to make a question out of the syllabus, but obviously they maintain the something. So yeah, that I'm not making. So when it's very simple that when every instructor when teach everyone follow the syllabus. However, a fine line there is a difference. So when I make a question, I know that which angle I focus, and then my student will do great, and the which angle my student will face the challenge. So that's an advantage and disadvantage when instructor make a question and when department of third party questions come. So we now all know because most of the students from the last semester. So yeah, we know everything. So that's why we are focusing also other part, correct? So that you guys can get as much as points you can. But I believe that if you study, you will do good. What do you already know about the ideal gas? Yeah, we know the solid compared to solid and liquid gas particles are moving randomly. They don't have any intermolecular force between the molecular particle, or like solid particles, they don't have nice arrangement. They don't have their own shape or something like that. So what they have then? The density of a pure water at sea level at 298 degree Kelvin on an average day is 1 gram per ml for liquid water, while it is 0.00074 gram per ml for gas water. So you can see the difference, the liquid and gas. So gas particles are more spread out than liquid or solid particles, and also they have a less density than the liquid. Gas are in constant transitional motion. That's why we need to talk about the kinetic energy. We will see the mathematics and equation, and also they experience the vibrational or rotational motion. And so it also influenced by the high temperature or pressure. Gas are very weak intermolecular phase, as you can see that they don't have this type of bond sometimes that we saw between the solid, high and liquid also sometimes. But in case of gas, we don't have it. Ideal gas, just simple question. Do you think that ideal gas is exist on the earth, or this is just a theory? What do you think? Ideal gas don't exist on the earth, but ideal gas like uh, theoretical discovery, but ideal gas is very useful to explain the lots of angle or properties of real gas, because some real gas like nitrogen, hydrogen, helium, they also follow as they also can be work as an ideal gas under certain conditions. So that's why normally ideal gas is just theoretical things, but it helpful to explain the real gas. And some real gas, as we know, the nitrogen, hydrogen, or some, they can be behave like a ideal gas under certain condition. That means if we modify some pressure, temperature, then they sometimes can behave as a ideal. So, the model consists of four postulates that explain the behavior of ideal gas. What are the four postulates? Gas molecules have no volume of their own, we know that. Gas molecules have perfectly elastic collisions and are in constant linear motion. Gas molecules experience no intermolecular forces between one another. Kinetic energy gas of an ideal gas is directly proportional to its temperature measured in degrees. So that means if we increase the temperature, the motion of a gas particle will be increasing, because this is a proportional relationship. So there are four terms that normally the behavior or properties of ideal gas. An ideal gas differs from a real gas in that molecules of an ideal gas. So what are the four terms we saw? We have to answer on basis of these four properties is actually here. So the question is asking the difference of ideal gas from a real gas. So let's have a option. Have a molecular weight of 0, have no kinetic energy, have no attraction, have appreciable molecular volume. So let's see the answer option. Have no attraction for each other, because gas molecules we know have no volume their own. Gas molecules elastic collision. Gas molecules have no intermolecular force and they have the kinetic energy. So that means this one is the ideal gas differ from a real gas. So this is the difference from real gas. Now let's move on here. Why we need to study the ideal gas? In the beginning, as I said, that some real gas behave ideally a lot of time under certain conditions. So gas has elements like nitrogen, oxygen, neon, nitrogen, oxygen, neon, and helium behave ideally at room temperature and pressure. All real gas behave ideally under conditions of high temperature and low pressure. So that are the things that we need to study about the ideal gas, gas laws or something. So as I said that some real gas, they can behave like a ideal gas at the room temperature and pressure. See that you need to be a little bit of remember nitrogen, oxygen, neon, and helium. And all real gas can be behave ideally under certain conditions. I say the reason the certain condition is either high temperature or very low pressure. So these are certain criteria that real gas also can be behave as ideal, and this is the reason we need to study the ideal gas, because it's a simple question that if ideal gas don't exist, so why we need to study? So this is the reason we need to study. While it has some limitations, the ideal gas model allows us to accurately predict very many gas behavior. We have limitations since you know, the steam engine, the very old fashion when the first train invented steam engine. There are so many things that based on this ideal gas behavior and so many advanced technology today we have. So we have four properties are variable in case of ideal gas. So the properties are actually the pressure, volume, number of moles, and temperature. Pressure, volume, number of moles, and temperature. And this is our straightforward ideal gas law, P V equal to nRT. So now if you look into the relationship of this variable, it seems that the pressure is directly proportional to the mole, R is the gas constant and the value is always fixed, and this is the temperature either in Kelvin or degree Celsius. So now if you look into this equation, they are the proportional relationship, but the pressure and volume relationship is inverse proportional relationship. Okay, so now why I want to give you one example. Let's see, we have the two balloons. This is, let's see, this is our number one balloon. We have the 2, 4, 5, or let's see some random particle, moles of particle. Now, if I decrease the size, what will happen? Anybody have a assumption? If this is the volume of balloon, and let's say it has some moles of gas, and we will not change the amount of gas, we will just decrease the volume. So pressure, will it be any effect on the pressure? Yeah, anybody. It's okay. Share with me. Because it's very simple. When you have a big volume, same number of gas particles in the balloon, and when you are decreasing the volume, the pressure will be increased. Because the same number of molecules within the small space, they will have the extra pressure because they will keep continuing the moving, correct? So this is the relationship I tell you, the inversely proportional. So if we don't change the number of mole of particle or amount of gas particles, so when we will decrease the volume, the pressure will be increased because when gas molecules are moved, kinetic energy, they collide to other particles, correct? So when the particles will have the more space, their number of collision will be decreased, correct? The pressure will be decreased. And if their collision will be high, so obviously pressure will increase. So this is the one of the important things you need to be learn here. That other variable is a direct proportional relation, but with the gas, this is the inverse proportional relationship. As I said that we guys have to do lots of math related. Maths are not tough, but you need to be remember that which equation and how we have to. Sometimes we give the equation, but for the final exam, I don't have an idea So be prepared for small things. But as we know that periodic tables are allowed, calculators I will allow. So yeah. Temperature, pressure. We measured in atmospheric pressure. This indicates the number of collision, as I just explained. Volume in liter, number of particles in mole, and temperature in Kelvin. So if we need to convert the Kelvin to degree centigrade, so you know there is a 273 you need to add. Number of moles of gas. Number of moles N indicates amount. This indicates how much matter the gas is made of. Moles are related to mass and molar mass. So molar mass equal to grams per mole. We already know because we did a lot of maths related to this, correct? So now we know that. So 1 mole equal to, you remember the Avogadro number? 6.022 10 times 23 particles. So since the gas we need to be keep in the closed system and the container, so we normally do the volume, this 3 cube, 1 volume equal to 1 centimeter cube or 1 cc. So if the volume equal to 1 ml means 1 cc. Okay, just to remember the container cube, fill the container with gas. Even when you go to the gas station, I think you also buy in a liter, correct? Yeah, so this is how we have to calculate the volume. Here we have the temperature and pressure equal to force divided by area. So in that case, as I already said, that if you consider the volume, there is a 2 container. If you have the same amount of particle, so here you have to measure the pressure, you have to find the force per area, and here also because it affects. So the unit for the pressure can be confusing. SI unit, Newton per meter square, and 1 Pascal or PA. 1 standard atmosphere equal to this pressure and this kilo pressure. 1 standard atmosphere equal to 8. We normally write a 1 atm. 1 atm equal to 760 millimeter mercury or 760 torr. So let's you see in this chapter that you obviously need to learn and memorize the basic things of this chapter, correct? This is the totally basic some information. You must memorize the ATM to me and all because they are not good. Sometimes they are, I'm not sure, but this is very common, like alphabet of this gas chapter. So you need to actually know. So just to make sure because yeah. So what causes the pressure of gas? The pressure of gas is due to collision. Gas particles collide both with one another and with the wall of the container. See the wall of the container. Only the collisions of the gas particle with the wall of the container affect gas pressure. Collision between particles affect the individual particle speed, but the kinetic, let's see here. Here we need to be again a little bit of understand. So the collision here will affect those individual particles, but it will not affect on overall kinetic energy. Overall kinetic energy means we know the energy in a motion. So the total kinetic energy of a gas particle into the container, that will not affected by the collision of individual particles. So if the two particles collide, they will have a they will affected by each other. Only the collision, like this particles is moving to go there, This particle is going there. This is the wall of the container. So these particles will affect the gas pressure, but not the individual. What causes the pressure of gas? The pressure of gas due to collision. I mean, same things is coming now. Now, how many collisions there are and how hard the collisions? So, how many collisions? This is the frequency of collision. So that means here time related, correct? And how hard the magnitude of the force of collision. So frequency here time how many and the how faster or how slow, what is the force, like when two cars, especially the local road, get to that accident, and in the toll road get to that accident is totally different, but because on the highway the vehicle moves very faster, right? So when they come to collision, the force and the dangerous thing and the local road low speed collision is totally different. Huh? So that the things is here, that the collision how force or how hard. So this is the one thing, and how many, that's the another things that are the important parameter when we calculate the collisions. Now let's come for the equations. Now we know we don't need to be talk here anymore. So we will see some math problem, and these two slides we already talked. So pressure, volume, number of moles, temperature, and gas constant. Gas is always fixed value, and this is their value. So, we already talked that pressure is proportional to the number of mole, pressure is proportional to the temperature, but inversely proportional to the volume. And how? We already explained. So, if we need to rearrange the equation, so we know the PV equal to nRT. So, that means R equal to PV divided by NT, correct? So the purpose to write the rearrangement, it depends because you need to do the mathematical, you need to do the problems related to that. And sometimes from the ideal gas law, we have the different types of law by putting the variable, the different value. So that's why you will see sometimes the rearrangement. This is called a compound unit and reflects the 4 units of the 4 variables. You must memorize what unit to use and the numerical value of R. So that means in the slide, since this slide, this presentation comes from the department and that are correlated to the syllabus. So try to be practice and remember what they are asking you. Now the ideal gas law can be again rearranged. See, we saw so many different types of rearrangement. So it depends on that what you have in the problem, what are the value you have, and what you need to calculate, find out. On the basis of this, you can rearrange the equation. Like here, if we want to be pressure, so we can write the equation like that. Even we can do like that, because sometimes the mole we know, so we can also rearrange like that. The pressure will go down if you decrease the number of particles. So because this is the proportional relationship, remember. So I want to give you one more time basic. What does it mean proportional relationship? Inverse. Proportional relationship between the two variables means that if we decrease one variable, then the second variable will also decrease. If we increase the first variable, second variable will be increased. This is the proportional relationship. For example, here, P proportional N. That means if we increase the pressure, number of moles can be increased. If we decrease the pressure, number of moles can be decreased. Like that, in terms of pressure. And when we talk about the inverse proportional, like here, the pressure and volume. So that means if one variable decrease, then other variable will increase. So this is actually called the proportional and inverse proportional relationship that we always see in the science or chemistry. But in this particular chapter, you will see a lot, and maybe you will have the multiple choice questions on basis of that. So this is very important to know that what are the intervariable relationship. Then it will be easy for you to answer the questions. Pressure will go down if you decrease the temperature, because pressure and temperature is also the proportional relationship. So if you just remember this one, then you can answer lots of questions and have the guess of lots of questions answered. That pressure proportional to mole temperature, but inverse proportional to volume. Now, as we know, the mole, N equal to what? Mass and molar mass per gram, correct? If we have, we can find out the mole. So we can again rearrange those values. Here, let's see there again rearrange volume divided by N, RT divided by P. Molar volume equal to volume per mole. See, same equations, as I said, same PV equal to nRT, same equation, so many times you can rearrange and explain. So the molar volume equal to volume per mole. Okay. So this is also just coming from the rearrangement of this equation, PV equal to nRT. So this this N comes here, and this P go down, and RT divided by P. So compare the molar volume of hydrogen to nitrogen. This is called the standard temperature and pressure. Standard temperature or pressure means the temperature is 1 atmosphere, and pressure is 1 atmosphere and temperature is 273 K. There are so many math, you will see that they are writing only problem only STP. This is your intelligence. When you will see the STP, you will know that in this problem, pressure and temperature is fixed and the value is this for pressure and temperature. Okay. So now for the hydrogen gas, if we consider, we can put the R T divided by P. So that means the molar volume equal to volume per mole. So volume per mole equal to hydrogen gas, this one. For the nitrogen gas, this one at STP. So 1 mole of any ideal gas at STP will have fixed volume. Now got it the things? That at STP, 1 mole of any ideal gas will have the fixed volume, and this volume is 22.4 liter. So this is the important things that we calculate and learn from here. Now a single state gas law problem. Calculate the number of moles of gas in a basketball that is inflated to a pressure 4.2 psi with a volume of 3.2 liter at 25 degrees Celsius. So there is a basketball, we need the gas on that, and that is inflated with the pressure this amount. You remember, when I was child, I had a wonder that, we found the bicycle, and it got pressure, and it was. So when I was child, it was very wonder for me, but I still remember that when I go to high school, then I start to learn, and my lots of wonder go down. So here, if we put the gas pressure inflate and with a volume, so then we have to calculate the number of mole. So we know our law, and we have to find out N. So what we have, let's now see. So if we rearrange the equation, we will have a PV divided by RT. So we have P, this is the intelligence that when you do the math problem, write the parameter value, what you have. This is, I start from my school life, still I follow that, because that helps me not to mistake my job. So we have pressure P 24.2 psi. Then we have volume 3. Is this the room temperature? 0.6 atmosphere per 1 psi. Okay. So you have to convert the psi to atmosphere. Yeah, look into here. We have to convert here. Then we have volume 3.2 liter. And we have our gas constant, this value. And we have temperature, degree Celsius, so we have to make it Kelvin. In most of the gas cases, we need to convert it Kelvin. Please remember, because sometimes the Celsius degree Kelvin, if you confuse or mistake, then your result will come mistake. So then you will find your mole value. This is not a tough, this is your practice. Calculate the number of moles of helium in a helium balloon that is inflated to a total pressure of 120 pk. So maybe in my case, the lecture exam, I'm going to give you the value, but I'm not sure about the final exam. Maybe they are big value, maybe they are going to give you, but some value maybe you need to little bit of memorize, especially the slide where they are asking you to memorize. Please make sure, see here, like what are the value they are asking you to memorize, follow that. And the 18th topic, I must say that so many topics, and we follow only one book and make this presentation. So the asked question is the total average question, and asked question go to all the college university across the United States. So they make the standard. So obviously the question level is different than individual teaching. Obviously it should be the same as a syllabus, but I'm not sure the toughness or challenging levels. So yeah, so we have to put the value and we have to find it out. Single state problem, because next we are going to have our P double state, P1 B1 equal to P2 B2. I mean, the divided by R1 R2 like that. So this is called the single state problem. So we have T Kelvin, P atmosphere, R atmosphere per mole, K. So now we have to put the value, you will get the answer. Single to double state, just we saw the single to double state. If we know 3 of these variables, we can always find the 4th. Yeah, because we already know the R. So we have the mole 4 variables. So if we know the 3 of them, we can calculate 1. Like if we know the volume, mole, temperature, we can calculate the pressure. So like that. These are called single state ideal gas law problems. We can also consider a set of changing condition, and this is called the double state ideal gas law problems. So the double state ideal gas law problems, we have that PV equal to nRT by itself and cancel out all other variables that do not change. So in that case, the R we will be cancelling. N maybe we are going to keep N, but if we have a problem that N don't change, that time sometimes your math problem need to write the N initial and N final the same. Sometimes you may see, because I have seen when I teach in others. So maybe we will also see here. So let's see. So anyway, so then we will have this law. This is called the double state ideal gas law. This is the initial, I means initial and F means final. So this will be our, or sometimes in many books you will see like P1, V1 and P2, V2. You will see many books like this type of equation actually represent the same thing, initial and final. Consider a sealed sample of gas at the 33 degrees Celsius, pressure 744, and yeah, they have here the pigeons. New York City have a lots of pigeons. Huh? In my room, my pigeons are pigeons. How to say? They lay eggs on my bedroom's AC. They eat there. They did everything, and my AC not working. See, there are so many. So they did everything day by day, they, and sometimes they destroyed that thing. Consider a sealed. But in my house, lots of pigeon comes in my kitchen window because when my boy was little, I give them rice and pigeon comes. It was easy for me to feed him. So still I live in the same apartment like 8 years. So still they are coming. Especially the not winter, they don't come, but once the ice go over, they start to come. Like now I come, before coming I saw the pigeons are ready to welcome me. I put some I put some rice in the kitchen window, and then I come back. Even some pigeons know me. When I close to my apartment, huh, they come and they gather in my window. Anyway, consider a sealed sample of gas at 33 degrees Celsius, 744 millimeter mercury, and 450 ml. This is volume. So if pressure decrease, see now see the double state condition. If pressure decrease and the temperature is raised, what is the new volume? So here you need to write it first, that what was your initial pressure and temperature. This was your initial pressure and temperature. When it decrease, it comes change the temperature, and so you need to write a new volume of the gas. So that means you have the P1, V1, even the T1, and you have P2 and T2, but you don't have, sorry, I mean VF, actually T2, like in many books we do the P1, V1, sorry. So you need to find out the VF. So these are the very interesting, easy, do the practice. Other information in the ideal gas law. The last one we have that the mole. Okay, so now we have 6 variables to consider: pressure, volume, mole, temperature, molar volume, and density. So see the breakdown, the fragmentation, I mean I will say the fragmentation or breakdown of gas law. I want to show you just that we start from here, then we modify it. This is the way we know that we even the modify, and we know the molar volume, how to calculate, and then we modify it from the single state to the double state. Now what we have to do, now we will add more branches. So that is the in this chapter last branches, the 6 value. How we will put the this n, we will put this n value, the see n value, and also we have the density. So if we put n mass gram like that, and then we will have the density mass volume. So that means we can correlate the n value with density, volume, molar volume, everything. So that's we are going to see here. See, if anybody forgot the density equation, just remember the DMV, New York City Motor Vehicle Department. DMV. You will never forget DMB. Okay, so this is the density relationship, and remember PV equal to nRT and n equal to m divided by, see, the molecular weight, and this m is here. Now we find how we are branching the equation. So rearrange the equation to isolate m divided by v equal to density. So m divided by v equal to this one, and this m divided by v equal to density. So that means we can find finally the density equal to constant mw. P divided by RT equal to constant in that case. So the density of a gas is proportional to its molecular weight. So this is, we find the relationship between the gas law and density. So please work on that. What is the density of a fluorine at STP in gram per liter? STP means the pressure equal to 1 atm and temperature 273, I mean in Kelvin. So in that case, we need to use that equations and see the 38 gram per mole. Yes, see 38 gram when we calculate here. So that you will find this amount, the density. Density unit is always gram per liter. Okay, now you can see that how your previous chapter is correlated to other chapter, correct? So if we don't know the how to calculate the molar weight, mole, it's going to be confused. But now if you know, it's not going to be confused. So if you are given the density of a gas at a particular P and T, particular STP, that's I'm telling, you can find the molar mass also. Density of gas depend on molar mass or weight. If you are given the density of a gas in particular P and T, you can find that. Yeah. So given that the unknown diatomic gas has a, but remember one thing we learned today, that if we have the STP, all the gas have the same volume, fixed volume. Remember, we just few slides ago calculate and we find that. This is a kind of exam material. In this chapter, so many kind of exam material we can make. See, when we have STP, the gas volume is fixed for the gas, most of the gas. 1 mole of any ideal gas at STP will have the fixed volume at STP. So if we have an unknown diatomic gas has a density and STP, identify the gas. Here are the things. Interesting. If you know the density and if as STP means the you know the fixed temperature, pressure. So you know the density. So you can find the molar mass. And when you find the molar mass, see 32 gram per mole, you know that this is the molar or atomic mass of the oxygen, 32. If you look back into the periodic table, the atomic mass of oxygen is 32, correct? Yeah, that's the oxygen, oxygen atom is 16, 816, but this is the diatomic O2. So obviously for 2 atom it will be 32, yes. So that means you can calculate the molar mass of diatomic gas if you know the density at STP. But sometimes this type of problem is come on exam to confuse the student, but actually nothing to confuse. You know that the density and STP means 1 atmosphere pressure and 273 degree Kelvin. So if you put, and remember the O atom and O2, this is the molecule. So obviously we have to consider the 2 atom. So that's why this is 32 means the diatomic gas is oxygen. So these are the summary relationship. final, I think this is the final one we have. Kinetic energy of gas. We already know the gas are moved. Kinetic energy means the energy in motion. We find it. So kinetic energy equal to half mv square, and this is the fixed established law. This is also you need to remember. So the individual gas particles are all moving at the different speed and have different kinetic energy. You remember just we talked that we can calculate the total average kinetic energy, and when the two particles collide, we can they can individually influence, but they doesn't have too much effect on the total gas. So to find 1 Ke for the whole system, we will find the Ke average. Now got it what we learned few slides before. So the kinetic energy average equal to half molecular mass, and this is the volume RMS. This is called root mean square. Root mean square of the velocity. Root, you know the root mean square. Root mean square, we write like that. So yeah. So V RMS square. The average molar kinetic energy of a gas system is related to both the average speed and the internal temperature. So Ke molar. So what the major focus for this chapter, that you need to remember the what you guys can do. Take a one paper, take a single paper from the beginning of your presentation to last. How many equations you need? Number wise, write it down, and that will be the enough for review this chapter, correct? So when you will look into couple of times the equations, you know that how many equations I need to know, correct? This is the way to study. So when you will write all the equations and the variable name in the right side, you know, and little conditions, that's enough for this chapter, because you need to remember some of the equations. So for any collection of gas, if they are at the same temperature, they have the same kinetic energy molar. If the temperature same, because we know that at STP their volume is same, and obviously then the kind of their pattern will be the same. So which flask has the higher kinetic energy? Both flasks will have the same actually, because we know that if they are same temperature, they have the same kinetic energy. So both will be the same. Let's imagine a model that consists of two flasks. Okay, each flask has a volume of 1 liter. Both flasks has temperature 273. So volume and temperature we know. What if we reduce the volume of the flask by half? So the temperature remains the same, but the pressure increases by factor 2. Yeah, that's the thing, that when you will change the volume, that will be only affect the pressure, because pressure and volume is inversely proportional. So if you decrease half, that means obviously the pressure will be increased by the factor 2. The thing is like that. Okay, I want to show you. These are same. Now you reduce the volume one half. One half means like that. So obviously the pressure will be doubled, correct? That's why telling the factor 2. But kinetic average will be the still same. If the temperature of a gas is raised from 150 to 300, the average kinetic energy of the gas. Yeah, so let's see this one. So in that case, you have to be come here, because we have the two temperature. So the initial and final. So we will write this one, and this is our temperature difference. T increases, kinetic energy increases. So we have to find out the result from this one. Finally, what we have, velocity or average speed of gases. You know, this gas, actually this is physics. physical chemistry topic. So physical chemistry is kind of mathematics. There is not so much things to understand that you need to know the condition, math, and problem. Condition, equation, and math. Condition, equation, and math. So can kinetic energy give us information about how quickly gas particles are moving? That means the velocity. So here kinetic average energy half molecular mass V square root the square root is sorry root is square, yeah, square root. So we can write the equation here and we can find the speed, the velocity V. So that means same same equation. If we rearrange, we can calculate the velocity. And if you look into here, the average speed of a gas depend on both temperature and molar mass. You can see here both temperature and because R value is the fixed, so it depends on the both temperature and molar mass. So these are the equations for the velocity. And now if you have the different temperature, you have to again use the V1, V2 or V initial, V final, and this you have the temperature. So lots of equation in this chapter, huh? Yeah. I will take the makeup quizzes. So you are the just only exception that you said that you did, but it was not showing anything. So I will also give you a chance. And there are a few other students who show me the technical difficulties. So I will announce the makeup quiz in person. Okay. So look into that. I don't want that everybody will go happily and one student have a problem. Let's do that. I trust it, so do that. So, but next time, always remember that when you do something, try to keep some. Nowadays, we have a technology. Try to record. Okay. Yeah. Movement of gas depends on velocity. Same thing. So we have to do that just math. Let's do this one. Consider a rigid tank containing hydrogen fluoride and hydrogen bromide gas. If this tank develop a leak, what is the ratio of the rate of effusion? Diffusion and effusion. You have two terms. I need to go back. I think this is I missed somehow. Leak is effusion in that case. So what will be the rate of effusion of hydrogen fluoride to the rate of effusion of hydrogen bromide at constant T? So what we have, we need the rate of effusion. So that means we need here this, the ratio of hydrogen fluoride and hydrogen bromide. So this is our equations. You don't need to show the equation derivation. You need to just do your job done and answer the multiple choice question here. So that was all about your topic 17. And next week we will do the 18, the last chapter. But Monday we have holiday, right? Hope you guys. Let's make sure that we have holiday. College is closed.
Yes.
Let's make sure one more time. You have now lots of time for study, so focus on that and you will find all your update on the blackboard, and we will see next week Tuesday. And today obviously we have the last recitation for the section 2, and section 1 will do that. Oh, okay. So section 2 will be finishing the recitation today, because according to the syllabus we have 9 recitations, correct? Because every recitation, how many points? Let's go back to the syllabus first, then we can see it. We have time. So wait a minute. Announcement. Yeah, because I remember that I made the point like that. I think I gave the 1 point then less to yesterday. I have to just figure it out. The edit the point. This one is the total recitation 9. Yes, total 9 recitation. So remember that before the lecture exam was one assignment and the recitation 6, I think. So section 2 will finish the recitation 9 today, and the section 1 will finish next week Wednesday. Since Monday is holiday, I don't know why section 1 comes couple of holidays. Yeah. So that's the things, and quiz we need to do couple of. I will announce. I think today is 30 June. Yeah, today we have one quiz. Okay, I will announce it. Yeah. Today we have one quiz. And about the recitations, I want to say something. Whatever the student you have here, you know, recitation is a group study, group one. So if you have any emergency, you are not present here, your team members put your names during the submission, you guys are okay. But make sure that you are absent, your team member didn't put the name, then you have to give him, okay? Normally we don't allow that view, but since you most of the students already had one unsuccessful semester, that is the reason I want to give you still chance that make sure with your team members that you are absent. If anybody, if no, then very fine, correct? If anybody that you are absent and your team member didn't put your name. Because if your name don't have on the list, it's very difficult to give you the point without any reason. So this is make sure, and this thing, same thing I'm going to announce on the blackboard, okay? And also I want to just make sure that some students ask me that Professor, if we have to do the individual, no. Submission was always group. I think I was just of these issues that some students, if don't come every day, regular basis, they need to get difficult, huh? So make sure that if you are absent or not with some reason or emergency, your team member put your name on it or not. Because now this I'm going to now summarize you all the grade and points because I need to grade lots of things from by percentage. And your final exam will be 12, and I think by 15 or 16, 18, I have to submit the final result. But I have to finish also because I may have some pending and some other work. So I will already start your all the analysis ready. So just to make sure by your responsibility, and if you think that you missed something, let's give me, I will correct it. Okay? But one more thing I want to say, please use your Google Chrome as a browser during the second lecture exam because we don't have so much time that I can give you the makeup of the second lecture exam. Correct? It's not possible because final exam will on the way, lots of things we have to do. So try not to use the Safari because I remember for one student, I copy paste lots of questions and actually I was last time present for proctoring, but the fact is that I could not do the proctoring because of those little issues. Like there was 99 students, 94 students was okay, and 3 or 5 students had issues or problems. So please try to minimize issues because this time we don't have so much time. So yeah, I hope you guys will try to understand. You will find a couple of announcements. So focus on that because announcement always go to your email also. So check your email, keep update. We need to do some quiz because quiz will be the 10, but recitation will be finishing soon. So maybe I'm going to give you quiz. Today I will give one. Maybe tomorrow I can also give you one since the Monday is holiday. Okay, and this will be a good practice too. So that was all about today, and now the section 2 will do the